Welcome back to the penultimate episode of Voyage Beyond Earth. Today we talk about a few ideas we've had to travel to other planets and what might the travel be like. All this and more on Voyage Beyond Earth. Let's get straight into two ideas of space travel. The Starshot program is a breakthrough initiative program that proposes the creation of a light sail in space, with highly energetic lasers aimed directly at the spacecraft, accelerating it to 20% the speed of light in 2 minutes. And we could reach Alpha Centauri, our closest star system, in 20 years. This is the same system with the planet Proxima Centauri b that we discussed last episode. You may ask, a few episodes back, I had said that our fastest rocket had only ever traveled 0.05% the speed of light. How can we suddenly travel 20% the speed of light? Well, this is because even though light photons don't have mass, they do have the ability to push. The next proposed method is the EM drive. The EM drive is also called the impossible drive. This technology works by capturing solar energy and converting it into highly charged microwaves that bounce around inside the conical chamber and somehow propel the craft forward. NASA scientists in fact put this to the test last month in a vacuum chamber and eliminated factors such as air, heat and pressure. The machine was somehow able to produce 1.2 million newtons of thrust per kilowatt of electricity, which would be provided by the solar arrays. No fuel intake, no exhaust, and most of all, the world's best engineers still do not understand how this technology works. Because it violates Newton's third law of motion, for every action, there is an equal and opposite reaction. If this technology somehow works, we would have just unlocked the secret of deep space travel. With the fuel mass being zero, we can exponentially increase our payload capacities. There are several other ideas, such as exploding nuclear bombs behind us and riding the sonic wave through deep space, or even a device that collects gas and dust from space and puts it under enough pressure and heat to create a fusion reaction that propels the craft forward. But as you can see, most, if not all, are just ideas. This is so theoretical. Maybe a practical real-life engineer can help us understand aeronautical and astronautical tools that we would use for deep space travel. Okay, so today we have Dhruv. He's a third-year aeronautical engineer and he's going to answer a few questions that even I have. So, hi Dhruv, how are you doing?
I am very good. I just wrote off my exam and preparing for the other one.
So my first question is, what got you interested into aeronautics and what is aeronautics?
I have to start from the beginning then. Like I'll say when I was 8 years old or around that years, I used to always look at the aircrafts, flying aircrafts, and always used to wonder and always had like questions how things work. I mean, you see an aircraft flying in the air, and the first thing you imagine, how is that possible? How is that happening?
Do you have any hobbies that are related to this field?
All right. I'll tell you, when I was in 10th standard, I believe I had enough knowledge of my mathematics and physics that I can start building or start thinking about making something which can fly. I have been participated in like 12 national events. Now these events tell you to design an aircraft to like the lightest aircraft which can carry maximum payload. Your payload is the weight, extra weight you put on the aircraft, which is not including the aircraft own weight. So all the 12 competitions we have been to, and there 2 competitions were like flying, like performances, the 3D air shows and all you do. And the other 10 competitions had the same thing, the payload versus the empty weight of the aircraft competition. Built some helicopters as well, and still many projects are pending. So hopefully by next year I'll be getting into some new projects.
So this episode is about how we're engineering our way into deep space. So could you give us any insight on what it might be like from any experience you've had?
We do have a subject called space technologies. So since I'm in third year right now, this was the first time the subject was introduced to us. Right now, it's being taught to us like how are the spacecraft designed? What are the parameters you have to consider when you are building a spacecraft? Like, gravitational pull and kind of forces which the other planets affect on the Earth and the Moon, about the orbits and everything, the calculations regarding that, as well as like propulsion, aerodynamics. So we have learned that when you're designing a spacecraft, and what are the parameters again used in the terms of propulsion, how much thrust, and more equations are whatever is required, everything. And then it's called like your application. How do you use your spacecraft is based on you.
So lastly, is there anything you'd like to say to the youth that is interested in astronautics or aeronautics?
One has to get it from the inside. Any youth is interested into aeronautical engineering, he should have a very good command of over physics and mathematics. Basically physics and mathematics, very important. So if you see the other industry as well, people look for the you don't have to be average, you have to be above average. And that's what I mean, you have to get it from the inside, because if you want to do it, you will do it, right?
Thanks for the information, Drew. Now that we know the limits of the technology of the present, let's go fictional. We'll try and get to another planet and tackle any shortcomings or unanswered questions by NASA, SpaceX, or any other organization. Let's plan a trip to a planet 100 light years from Earth in the 22nd century called VBE 414. But first, we need to decide a crew. I mean, any successful trip needs a good crew. Ask this guy. Humans are social animals. Without contact with other humans, our brains can suffer serious psychological damage. Missions like SpaceX propose more than 100 people per flight. NASA usually sends 3 people per mission, but would probably send more than 6 for the first interplanetary mission. In my opinion, 24 is a good number of people going for the first mission, and I'll explain why in a little while. Using a combination of traditional fuel and a light sail 10 times as big as is proposed today, we could accelerate to 30% the speed of light, making us reach the planet in a little under 340 years. Using a toroidal spacecraft and simulating artificial gravity, kids could be born in the vessel in Earth-like conditions. Hence a crew of 12 males and 12 females would have to be assembled, each with a certification in 2 disciplines, such as mission commander, mechanical and systems engineer, doctors, surgeons, biologists, chemists, research scientists, etc. This is to ensure that if something was to happen to someone with knowledge in a specific area, another would be certified to take his or her place. These crew members don't just have to be physically fit, they'll be trained in a simulated isolation event for 1 year, together to see how they react. And that's exactly what NASA-funded Hawaii Space Exploration Analog and Simulation, or HI-SEAS, did this year. 6 astronauts had been living in Mauna Loa, Hawaii, for 1 year in a simulated environment to see the effects of human psychology and physiology from living in small areas and seeing the same people again and again. Nothing conclusive can be derived from this experiment, as tests are still being done on the astronauts. In deep space travel, there's one big problem: radiation. On a return trip to and from Mars, humans will receive almost 700 millisieverts. NASA guidelines say that astronauts should not be exposed to more than 1000 millisieverts in their entire life. And this 700 is only in the trip, not counting the radiation they might face while living on the planet. This causes bone density loss. It's 14% for 6 months on the ISS, so imagine the kind of weakening and fractures our astronauts may have to face. There are several proposed solutions, but first we need to understand radiation. There are 2 types of radiation we have to fend off from: the sun's high energy radiation, and the other is the cosmic radiation, mainly gamma rays and high speed neutrons. To break up this radiation, we need small atoms with tight, small nucleuses. Hydrogen is very good at this, and hence water is a good radiation protector. NASA even brought up talks of putting water on the walls that astronauts could remove and drink from. and a life support system would convert their waste back into that water that would be hung up on the wall again. Lead is also a good radiation deflector, especially for gamma rays. Lastly, proposed by NASA, boron nitride nanotubes could be used widely in spacesuits and in spacecrafts, as boron readily takes in neutrons, another form of radiation. Apart from this, there are several other radiation resistant and just strong elements we will need to construct the layers of our spacecraft, including carbon fiber. With all these precautions and regular exercises by these astronauts, we can drastically reduce the effect of radiation on the human body. Although shorter missions, such as the mission to Mars, would be reliant on Earth for food, on an expedition to be less reliant on Earth, we'll have to create our own food on the spacecraft itself. So let's say we want to make a burger. For that, we need to grow our own wheat for the bread, our own vegetables such as potatoes, lettuce and tomatoes, and any other trace ingredients. By 2100, we would have devised a way to create hybrid plants that grow much faster than normal and have bigger yields. Also, we would probably no longer be using geoponics, use of soil implantation, and switch rather to hydroponics or aeroponics that grows 3 to 4 times faster themselves. Although hydroponics has several advantages and aeroponics is a very new and expensive technology, by 2100, I'm almost certain we would have perfected space-saving and faster growing plants. This long-term mission would not be like a regular mission that we would send to Mars. It will need to have recreational facilities, hospitals and schools for the kids. It will be like a city in space. For that, we need extremely meticulous planning to look at different activities and filter out anything that could hinder the success of the mission. In tomorrow's episode, the last episode of Voyage Beyond Earth, we will be taking a journey to VVE 414. What do we do when we get there? How do we even survive? But most importantly, how will humanity thrive in this new system? Tomorrow on Voyage Beyond Earth.